Okay, so look, when Matthew asked me, asked me to give a programming language research retrospective talk. And at first I was like, oh, that's bad because I don't have that. But I had to say yes because we owe you all a lot up there. But to me, language design projects are a kind of community intervention. What you're trying to do is to get a certain group of people to talk about a certain kind of issue in a certain way. And when I started thinking about it that way, what I realized, of course, is that's what we've been trying to do at UBC for 10 or 12 years now, is try to get a certain group of people, namely instructors and TAs, to talk about how to design programs in a certain very good way. So what this is it's kind of a partial retrospective about that project, and with a bit of a focus on the last 5 years, when we discovered that really what might be key to achieving our goals was to make a little DSL. So you got a little DSL, you got a little retrospective. I'm going for partial credit. I want to start perhaps in an unusual way, but it's important. It's always good to give thanks, and this will also set up some of the context. I feel like, I got to do this without being emotional. I feel like I've had pretty much the best teachers you could possibly ask for. I'll start with a guy named Ted Sage, who nobody's ever heard of, but that's why I'm going to say his name. In 1974, he was teaching students, high school students, discovering programming, writing games, using a student-run lab in kind of the way that Brian Harvey would talk about several years after that. And I experienced that, and it was great. I don't know whether it's worse to speak just before Hal and Jerry or just after Hal and Jerry. Either way, it's not great, but I am very glad they're here, and especially that Hal is here. I took a draft SICP class from Hal years ago, and it kind of rekindled my interest in the field. And he then hired me to work on building the first Boxer system. And that was important because it was a time in my life where I needed a way to succeed that wasn't classes, and he gave me that. And for years after that, he continued to sort of steer me in better directions than I probably would have steered myself. I also at Park had kind of 4 other sort of de facto thesis advisors. And I learned a ton of things from them, but one which comes up today is really this idea that all technologies are socially embedded. So when you design technology, you're really designing social structure. And that can be very powerful if you understand it. Closer to home, I want to thank Matthias and Robbie and Matthew and Sriram and later Kathy and kind of all of y'all. You gave us words, or you gave me words to sing that kind of never stuck in my throat. That particular line's for you. That one didn't work for you, huh? It'll come back. I'll explain it later. It was a thing that Jerry said about Robert Hunter. And also, in addition to sort of a story that was kind of the right story, a wonderful platform to build on. And my goal has really been at UBC is, having had that incredible experience, to try to give something as much like that as possible to our students in a somewhat larger setting than one-on-one. So what would it be for something to be that great? There's lots of things, but here's a few. One is that it should be substantive. That's what SICP had, right? It was substantive. It was about important and deep ideas that lasted forever. And everybody in the class had some things to think about. It should be useful. One way of saying useful is that should you repeat something you learn in your co-op interview, they don't laugh. Okay? So it should be some sense of useful. Now, the BSL thing is kind of second order useful, but I think it's useful. I wouldn't be doing it otherwise. It should be challenging. I like to say in my last lecture that I would like to think that each of you has learned that you can solve harder problems than you knew. And I can't say that if I don't think it's true. I would like there to be a level playing field. I want to fight imposter syndrome by not giving some students, typically wealthy male students, an advantage in the classroom. That I'm not going to try to take away their advantage, but I don't want their advantage to be intimidating to other people. And these next two are kind of especially hard at scale, but we all know the troubles that students sometimes face, especially in big school settings, and we have always tried to be able to make time to stop for that student. So how does our department, the problem is, of course, 48,000 undergrads. The class is over 1,000 people in the fall term. It's hard to do all that, or at least the way that I experienced it at scale. We have to figure out how to make that work. Now, the way the department, I didn't know that 4 TAs were going to be here. So I got to talk some hard truths about the department, okay? When you go back across the border. The way the department normally approaches this is by adding more sections and more instructors. And recently we've been spending a lot of money on course coordinators. Thank goodness, they're wonderful. And we make the sections somewhat bigger. We have a school that decided to grow from 20,000 to 48,000 without building any large classrooms. So that was an interesting choice. There's almost no rooms at UBC larger than 250. So this top stuff is sort of, easy to say. And then what happens on top of that is that we have common material across a class and per instructor material. And that per instructor material can include not just lecture, but also lab, project, and even how the course is organized that particular term. We have a very expansive notion of academic freedom that means that sessionals, lecturers, professors, everybody kind of has a fair amount of freedom to do whatever they want. And more recently, we've been using random generated assessment to ease exam scheduling. What that lets you do is have 1,000 students take an exam without all being in the same place at the same time. Or so they tell me. But what we've observed is that this kind of growing leads to a number of problems, and most of those are rooted in the inherent inconsistency of it. What content is covered is inconsistent because there's multiple instructors who have their own material. How it's covered is inconsistent, same reason. Because one instructor can come in this term and say, well, we're going to do the whole organization differently. Even how the labs are run, the TA roles. Some courses use a different organization of lead TA structure term to term. Academic freedom, it's a good thing, yeah. And so you kind of get this inherent confusion, right? Like the individual student doesn't see all this unless they take the course more than once. But the TAs and the course coordinators see it all. And you get this place where people are like, yeah, this term we're doing, and I don't think that's great. It also leads to course coordinators being unhappy. They tend to leave pretty often. I sort of summarize this in this notion that I call least common denominator exams and least common denominator courses. When you have a class that has 4 sections run this way, what happens at the end of the term is they kind of find, well, what did we all cover and cover the same way, and that will be on the final. So substantive and challenging just went out the door. Because if the course is the least common denominator, and not only do students not get challenged, but the later courses leave aside how much of a prerequisite the students actually remember. We know that's an issue. But in a setting like this, you don't even know how much of a prerequisite they heard because of the inconsistency. And then in terms of the random generated assessment, I'm not going to talk much about this today, but it seems to me that random generated assessment is inherently inauthentic. I'm not aware that at Amazon, submitting the answer to a bunch of multiple choice questions is the same as committing an improvement to the code base. So I guess the way I think about it is as size increases, variation is not a diversity of perspective. It's a mess. When Hal teaches 6001 in the fall and Jerry teaches it in the spring, you've got interestingly diverse perspectives. Or if it's Matthias and Mitch, you've got interestingly diverse perspectives. When 4 people teach it all at once with different material, I think you got confusion. So what have we done? Over the last 5 years, we in our course have adopted a somewhat different approach. We've gone to fewer sections rather than more, and fewer instructors rather than more, and we've done it by embracing Zoom. So for better or for worse, we're all Zoom for lecture. Because there's fewer people, and because it's more important, we've gotten better at it. We're much better at it than we were 5 or 6 years ago. We're better at making it interactive. We're better at engaging a broader cross-section of the group. Look, it's still not going to be as good as if the class was this size, okay? But we're much better at it than we used to be. And there are, of course, some ways in which it's better. Because Zoom has live transcripting, the English as additional language students really find it much easier than they find lecture. And since they're at such a fundamental disadvantage in the classroom, that's kind of a good thing. We've got a single master set of lecture and lab material. The idea was that would eliminate a lot of inconsistency. Except it turns out we don't, because this term we've got somebody who's decided to make their own version of all the slides. And so we've introduced some problems because some of the in-class assessment questions had errors introduced to them. And so we got a problem, right? I get so tired of explaining that any reasonable programmer knows there should never be 2 slightly different versions of the same thing. But I'll put that aside for now. And I'm going to talk about these other things a little bit more right now. So we have we've made the course coordinator a co-director. It was easy to do because Emily was first a 12-term TA in the class, and she's been course coordinator for about 4 years now. It's very counter to our culture. In our culture, the faculty tell the course coordinators what to do. But I just say that Emily and I run it together, and in point of fact, Emily and I run it together. And there's decisions that, we consult each other. We don't just do things without the other person being aware. But if Emily says, this is some aspect of how the scheduling should work, I look over it because I should, but she's right. And what this does, and this is really important, is it creates a center of mass for policy and administration. A new instructor comes into the thing, and there's no sense that, gee, they should figure out how, what the weighting of problems of different kinds of assessments will be this term. Because Emily's got this whole website, and it's all da-da-da, and it kind of just says, this is how 110 runs. It doesn't mean it can't change. It just means it doesn't change every term, right? There's a sort of momentum there. And partly there's momentum because other instructors come into the thing, and they're like, wow, Emily really knows what she's doing. I'm not going to screw with that. We've also worked very hard to build a lasting TA team who are so excellent that some of them drove down here. I did not even know that. We have about 30 to 50 per term. Many work 5 to 7 terms, some work 10 to 12 terms. So we're really trying to keep them. Our basic strategy is we're on the lookout in the first year, and we hire them right away before they take any other courses, and other courses might decide they want them. We hire them right then and there. And we hire them for different kinds of best. Obviously, getting 100 in the class is a best, but speaking well in lab is best, speaking well on Piazza is best, being a kind person is best. We try to take a broad sense of what best is. We invest a lot in their training. I'll talk a bit more about that in a slide. And then we have a smaller core team that with the coordinator and I run the core of the course. I'll talk more about that in a second. And we work a lot to let them know how appreciated they are. The obvious things, we thank them, we praise them, we feed them. We didn't have donuts for the midterm this week, I realized, but we will for the next one. And we support the culture they develop. This is hard when you're 64, but we try, right? So they insist on using Slack. I hate Slack, but I use it anyways, because it's the thing we use. It's important. They're the ones doing the work. Let's talk a little bit about training. Let's talk about the core team. So the core team is 6 TAs, 3 pairs of 2. There's always a more senior and a more junior. Their work is divided into 3 categories. One is the server Autograder TAs, so they run the grading infrastructure, they help write exams, they help write graders, they kind of keep on top of all of that. It's really fantastic now. We can, in the end, I've got to look at the exams super carefully, and I don't always find everything. But a lot of the bringing it together is done by them, and thinking of novel, you got to think of an arbitrary tree of some new thing, and they're much better at that than I am. We got 2 misconduct detection TAs. I sometimes call it misconduct data science. It's my way of making an awful job sound less awful. But we've got some very creative people thinking about how they can look at our submissions and find misconduct. And sometimes they do much better at that than you would like. I mean, not that you would like, but sometimes they discover more than you would like. And then we've got 2 lab coach TAs. That's new. And as with the coordinator, again, the goal is for these 6 TAs to be so good at their job that when new people come into the class, they're just like, okay, I'm not going to touch that. And they are. I look at it mostly and say, okay, I'm not going to touch that. Weekly lab TA training. Okay, so our big thing here is 9:24. I got to move a bit more quickly. We started a bit late, right? Yeah. By default, I think new TAs think their job is to help students complete the lab. And we're trying to, in our training, replace that with your job is to help students do well on the final. And the first is not always the same as the second. So we've been training this idea of circulating to each student, scanning the student's screen, and thinking of the thing that you might say to yourself in this situation that would cause you to take the next action, and saying that and walking away. Okay? Because really what we're trying to do is make it so that, if you stay there for 20 minutes, they didn't solve the lab by themselves, so they didn't get any practice in solving things by themselves. And if the first time they ever solve something by themselves is a midterm, it's going to be a bumpy ride. So we train that in various ways. One of my TAs who's been working on this material is sitting right over there, so should you have any difficult questions about these next 2 slides, I won't be answering them. In order to train them that, we have several exercises that we do, but one works like this. We show them a sample screen, and then in 2 discussion periods in small groups, they think first of, okay, well, what's wrong? What's going on here? And then second, they think of, okay, but what's the first thing to say? Because we're really trying to get that idea that there can be lots of things wrong, but if you're just going to say one thing and walk off, you should kind of say the first thing. So here's a little example of that. That's what an HtDF problem looks like in our world. And so the exercise is the student raises their hand and says, I'm not getting 100% from the autograder, but my check expect is passing. What should I do? So, what's wrong there? Well, a lot of things are wrong there. The first is that the student's raising their hand in lab. We don't like to take questions in lab, because when you take questions in lab, a small group of people dominate all the airtime. We go around in circles. Everybody gets equal airtime. So that's the first problem. But another problem is, and this is unfortunately a fairly common problem, which is that the top line of the autograder had a score, and then they didn't read the rest of it. So probably the single best thing to say here is, what I would do is read the rest of the autograder report in detail to see what it's talking about. And you can tell me about that the next time I come back, walk away. But you could also say something like, what do the testing guidelines say about the number of tests for a function like this? There's several, there's some bad things to say, like pointing out this mistake right here. Pointing directly at that would be a bad thing to do. But there's several good things to do. But what we've discovered is this is really hard to ask TAs to do. right? This idea that they're going to walk up to somebody, say something, and walk away, leaving that person frustrated, that's hard. It's hard for a student to do that to another student. So we practice it, like we really practice it. Practice saying it. We talk about how difficult it is to do, because it's a lot we're asking of them, but we think it's a lot better. So that's some of the training we've done. Okay, the DSL part's coming now for all the racket people. One more bit of introduction. Course coordinator, TAs are the most important part of the team. Now look, we all know that for better or for worse, students pay attention to grades, okay? They just dramatically pay attention to grades. And that was something we were always frustrated about. But then we started thinking, well, maybe we could turn that into a feature. If we could get a grader that gave HtDF style feedback, that gave feedback on what matters, then the students are going to pay a lot of attention to that because that's what they do. And then we might get a whole lot of consistency out of that, because now everybody's looking at the grader, which produces the same thing every term, and every student, and every office hour, and everything. So we've been working on that, and we have a little DSL, and we have graders for 53 in-lecture problems, all our problem sets, all our labs, and 208 practice exam problems. And the students bang on this thing a lot. Last fall, they submitted 350K distinct submissions, so about 350 submissions per student. Now, did they read the whole way down? No. How much did they read, and how much could we, that's a study, right? That's the kind of thing Kathy would be good at. We're not doing a study on that. We do try to get them to read further down, though. I've actually considered just not putting the total at the top and letting them add it up. The way the DSL works is there's a simple DSL that mirrors the lexical structure of solutions. We have these metadata annotations that we teach as checkable design notes. We talk about, emerging type systems and the idea that there are checkable design notes. And these are checkable design notes. The Autograder is going to check them. There's a 3-layer structure to this DSL. I'm just going to talk about the top declarative layer now. So there's a how to design. We added a recipe called how to design data. There's a how to design data. The recipe isn't new. The name of it is new. There's a how to design data problem in our world. So that problem 1 tag says, until you hear otherwise, the rest of this file is problem 1. This says, until you hear otherwise, this is a data definition for grade standing. There's the type comment. This is the stuff you're used to seeing. And then the problem is we'll give them something like that and say, okay, we want the template for it. And in the early part of the course, we scaffold generating type-safe templates from type comments by having an intermediary, which is the rules. They can't just generate this. They have to say which rules produced it. And these are the names of the rules that produce that code. So that's the correct answer to a problem like that. We're good? Because this is so rule-driven, okay, the grader for this problem is very declarative. It looks like that. So that says grade problem 1. So find problem 1 in this file. Get me that context. This says all the parts of this are going to have equal weight. There's only one part, but I put the weights in there anyways. And then this says we're going to find the HtDP for grade standing. So all of that is kind of narrowing in. And then this says this is a DD rules and template problem for that type. We've had to fight moving away from type comments in the course to actual type expressions, because we wouldn't have to write them in the grader and we get a bit more flexibility. But I still like all the benefits of type comments, so we haven't done that. That's it. That's the whole grader for that problem. This is a very straightforward problem type. And it produces, oh, you don't need to know that. It produces a report that looks like that. It's really detailed. When it's all correct, it's a little less interesting than when it's partially correct. But in this case, it basically says, did you write the right list of rules? And for each rule, did you produce the right con question and answer? And so if you do read past the top line, you get pretty detailed feedback using the correct terminology about what you did and didn't do right. So if there's not a TA or instructor in the room, you're gonna hear the right thing. Here's an HtDF problem. Oh, let me back up and do this one quickly. The basic way it works is everything called grade something produces a score structure. A score structure has a percentage weight, a percentage correct, a percentage weight, and some text. It's not actually text, but it's a list of text, but anyways, messages. And subscores. So it's obviously it's a tree. There's inner nodes that have their own, that don't have their own score. They just have the sum of their children. And there's leaf nodes that have their own score. And everything called grade star produces score, and everything called weight star adjusts the weights. Okay, so there's a function design. It's what y'all know, with just a little bit of difference. The signature, instead of being in a comment, has to be in a tag, otherwise the grader can't read it. And then this thing here says, what was your template strategy? When you said to yourself, how am I going to template this thing, what was the answer to that question? In the early part of the course, we also require them to actually write the template. So first they say, I'm going to get it from grade standing, so I'm going to go grab it from here. I'm going to go grab it from here. And then they actually leave it behind. After the 6th week, they don't have to do this part here. They just say where it came from and the function definition. But again, this scaffolding thing seems to be useful to really make it clear. You start by getting the template. You know, we get a lot of people, you know, it's the usual thing, right? They don't go copy this 6-line thing. They don't go copy it and bring it down. They write it from scratch each time. And of course, right, you know what happens. Any questions about that correct answer? Yeah, we're all good on that, right? In this room. Here's the grader. We're grading a function called excellent. Everything has equal weights. This is a lecture problem, and in lecture problems, we don't tend to fuss too much about the proper weightings for things. We just tend to say equal weights. On exams, of course, we pay more attention. The signature should be that. So this grades the test validity. For each test, it evaluates the left-hand side and binds the arguments to, in this case, just one thing, GS, and evaluates the right-hand side and binds that to R. Binds R to that the other way around, sorry. And then every test must satisfy all of these validity conditions. I'm using 1980 style hygiene here with this %% thing. Those are definitions that we dump into the student namespace. And I actually, in this particular case, like it that way because you have to be able to call both right next to each other. And I just think it's simpler. But, I'm old, what do I know? So this says, GS better be a grade standing and their function better produce the same answer we produce. You could write something different here, something more elaborate, but we often tend to write just that simple thing. So that's the validity. Any test that doesn't satisfy both those conditions just isn't valid. And we do a thing that we got from Sriram's student, graduated last year. Yeah. Which is, we have cooldown in our autograder. After you submit, you have to wait a while to submit again. But for validity, for signature and validity, there's no cooldown. So we're basically saying, you can resubmit on validity over and over and over. Why bother to write the rest of the function if you still don't know that you're writing the function we want? I know the real world's not like that, but I don't know, Jack's story seemed compelling, so we did it. This is thoroughness. Thoroughness is a little bit different. Once again, you evaluate just the arguments, so just the left-hand side of the check specs. And what this says is that for each of these conditions, at least one test must have satisfied it. So there's a boundary, there's an integer boundary in the behavior of this function right here. So since it's an integer boundary condition, we want to see a test at 89, 90, and 91. And we want to see a test for all 4 of those conditions. And of course, this is a very simple function. Sometimes the thoroughness is more complicated. One of the things that's been really great about the thoroughness, there's always too many people who got 100, right? And not that that's not wonderful. But you would like a little bit of making it more challenging. And now that we're grading thoroughness, the students who are having an easier time with the rest of it can really spend more time on thoroughness because they're getting 99% because they're missing one thoroughness condition. And they can really kind of think about what's going on there and spend a little extra time. They still get to 100, but it takes them 1 or 2 more submissions to get to 100. This says the template origin is grade standing. This says the template, the one that you stick here, has to be based on grade standing. This says that when I look at the function definition, I better see that template. The type safety of that template better be intact in the actual function definition. In exams, we always ignore submitted tests, but in lecture we don't. And then those tests better all pass. We're good on that? Yeah, in this room, you're not going to get a lot of questions. I already said all that. And that's the report that they get back. Signature's good, validity's good, thoroughness is good. That answer I submitted was correct. This intactness is pretty important, right? Because one of the things we're trying, we changed the name a little bit, right? We call it systematic. And one of the things we're really trying to stress is recursive type theories and these rules will generate type-safe code for you. Why would you just start banging on the keyboard? Why wouldn't you take this type-safe template and use it? We really kind of want the students to start to get a sense of, there's some science under it. It isn't just what I call banging on the keyboard. Every now and then I'll get a student who'll come to me in office hours and say, I know you're talking about me when you say banging on the keyboard, but that's just what I learned to do. But by the end, it works a bit better. So this intactness thing is really good because a student who just decides to throw whatever code they want to in there is going to get blown out on intactness. And at this point in the course, you might say it doesn't matter. But when we do graphs with 2 node types, and there's 4 types, and you've got to get the mutual recursions in the right place, right? You all know this, you've all seen it. The student who didn't know how to program at the beginning and just says, sure, yeah, it's all these templates, boom, 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 boom. These are the mutual recursions, and boom, boom. And the students who were just banging out the code can't do it. So really pushing on this template intactness thing, it's interesting. I think it helps the students who think, it criticizes the students who think they're ahead more, but it actually also helps them more. We've also got some other very focused one. This grades using a built-in abstract function. When you do a built-in abstract function problem, we give you a signature and some tests and just ask you for the function body. You better not change the signature. You better not change the supplied tests. You better pass our additional tests. And then this part lets us say, well, depending on what composition you used, we're going to give you a different amount of points. What we always do with these is on the exam, we're a little bit more generous with the alternative approaches. And then when we stick them in the problem bank, we tighten it back up. So, there's the kind of tutor is a bit more demanding than the exam grader. So yeah, map composed with build list is always the same as build list, but really we just want to see the build list. Okay. You could be more flexible, right? That says give 100% for that composition, give 40% for that composition. This one is just as obvious as could be. If you've got these definitions in that expression, we want to see the step-by-step evaluation. You don't have to write any more greater than that. But of course, it's real important early in the course for them to learn step-by-step evaluation so they can just drill on problems like this really easily. And we can put problems like this on the midterm and know that they're all graded correctly, right? 1,000 of them are graded correctly. We didn't have that before. This is a different kind of thoroughness. This is basically thoroughness by fault injection. What we do manually is we take the right function and we bake a bunch of simple mistakes. We do fault injection. And the idea here is that one of their tests better fail. For each of these functions, at least one test has to fail it. I would like it to be better. One of y'all can figure out how to do this. I would like to be able to just specify, have the right function, and then have some notation that says, right here, put less than, equal than, greater than, right? Specify the fault sites and the possible list of faults, and then have it generate this set of functions. But we haven't done that. There's more than this, but here's some other things we have. Grade constants use, grade test constants use. Are they using constants rather than the raw numbers? These three are grade that the natural recursion is intact, grade that the mutual recursion is intact, and grade that the natural helper is intact. Those end up being a little bit more entailed. They're not completely, you have to do a little bit of work to set them up. This grades that the accumulator template is intact. These are all basically, sure you might pass the additional tests, but is the structure simple? It actually tends to work the other way. On the final exam, on the big graph problems, you can get a number of students who clearly were doing what we wanted them to do. They had taken the templates, they'd written some good check specs, they were filling in the combination positions, they didn't quite get the graph thing to completely work, because they're kind of like an 85 or an 80 student. But they can still get a lot of credit because they were working systematically. I really like that, right? If it's just, well, did your graph function do the right thing? In the time setting of an exam, it's a little harsh. Later in the course, we replace grade steps with grade lifted definitions, right? It's too much to do step-by-step evaluation of local, but you can say, well, what are the first 3 lifted definitions? And that really shows, did they understand the lexical scoping? You know what it shows. You've done these problems yourself. Grade 2, 1 of, test the 2, 1 of. Grade prohibitive cause ends up being really important in the when there's 2 compound types, to make sure that they're not moving into a function that's supposed to operate on a foo, selectors for a bar. They get weekly reports like this. So they kind of know where they are, and they know where they are with respect to the rest of the class. It doesn't help that much, of course, because the median goes to 100. That's what happens all the time with autograders. But again, the idea is that's a feature because they're getting good feedback from our autograder. So what do we think? So consistency is, of course, much higher. Everybody gets graded on the same rubric for lecture, lab, problem set, exams. Whether it's right or wrong, they all get graded on the same one. And that's pretty good. Students don't naturally read past the top line, though, so you really have to work to get them to the rubric. Learning tougher issues seems better. One thing we know is that I cover the material in this lecture faster than an instructor who's doing it for the first time. I'm still like 0.2 of Matthias' speed, but I cover it faster. it's hard. A new instructor comes into this first time, it's a lot to cover. If they don't get to all the thoroughness, it's okay, because the autograder is going to get to all the thoroughness, and it's in the supporting material. So it kind of really, it frees them the same way the videos free them to rush less. What I sort of tend to say the first term instructors is, the smart move is to say 80% of it clearly, then kind of 100% of it not clearly, because you're backed up. Obviously 100% of it clearly is even better, but that's going to be pretty tough to do the first time out. That one and that one, they both did pretty well on the 100% first time out, but a little bit cheating. The exam grading workload is interesting. You know, the way it works is you run the grader, you check the rubric. They're brand new exam rubrics, and it's exam points. So we really do check pretty carefully, is this thing doing what we want, right? Grep mode in Emacs is wonderful for that. It still, on the final exam, takes me a couple days, but there's no TA time. And it's a lot more enjoyable a couple days. I mean, at the end, we were sitting in a room with 30, 40 TAs, and I was trying to overhear the things they were saying to each other, because the different subgroups of TAs would drift. And nobody was being bad or anything, but it sure as heck wasn't consistent. And, you know, I don't know, it's not fair. So it takes about the same amount of time. It takes no TA time, or except for the 2 greater TA times. But there's not 30 people sitting in a room grading. The students love it because their union contract requires them to stay after the exam until it's graded. So especially in December, you know, they leave as soon as the exam's over. Regrade requests, it's an interesting thing to regrade requests, right? Regrade requests used to be profoundly unfair, because only the kind of student who's used to speaking up for themselves would say, this is wrong. Now, if that student convinces us that a piece of the grader is wrong, we fix it and rerun it for the entire class. So kind of everybody benefits. And you know, we get fewer and fewer of those as time goes on because they find them. The DSL could be better in all sorts of ways. One of y'all is encouraged to do that. The weighting mechanisms I don't like. They're kind of too syntactic. Some of the flow analysis is you know, too ad hoc. And the template grading can be a bit more fragile than it should be. You know, have we solved the inconsistency problem? I don't know. As I said, we've got this huge center of mass here. And you know, the students learn to all of that, and the faculty teach to all of that. Because what the faculty do is they submit the lecture starter the night before. Right? They're working through the lecture problem, submitting it to the graders, seeing what it says. So everybody, including myself, is, you know, right, held to this thing. And because the feedback is pretty HtDF-like, as opposed to just correct or incorrect, you know, we're being held to a good thing. Is it ultimately good? I don't know. I feel a little bit like I joined the static typing conspiracy. And oh, sorry, did I say that? And now I'm not letting people write whatever they want. On the other hand, I spent 15 years not letting the students write whatever they want, so I might as well not let, you know, in a way, I do believe we've improved the quality experience for the students by making the whole staff and the whole process be held to a more consistent thing. And I'm pretty sure that's the last one. Yeah, that's it. Can we take a couple questions? Or?
Yeah, we have time for a few questions. So if you could come over to the aisle, actually, I'll take the question here. And say your name first.
Okay. Hello, I'm Ethan. Thank you for the talk. I wanted to ask, you had a very detailed rubric on the screen that shows like very line by line what has failed. And you were talking about students struggle to kind of read past the first line. And I have to admit, I did as well. I see that and my eyes glaze over. So I wanted to ask, have you played around with changing the format or like showing things kind of in line alongside the student's code or anything like that?
Yeah, that's a good question. Let me just say a couple things about it. One thing, I don't think they struggle to read past the first line. I think they don't read past the first line. Okay. That's different. Look, obviously, with the wonders of syntax, we could make each error message display kind of right next to where it's happening. I'm a bit conflicted on that. We could also just fix the code, right? I mean, in some sense, there has to be a little bit of a journey for them going from, I'm not doing this thing, where's that happening, how do I fix it? I'm not a learning science, but if I close that gap too much, then when they're sitting there on the final, or they're sitting there in their co-op interview, or they're sitting there at work, they got to be able to close that gap. So we have deliberately resisted going all the way to making them, right? Again, somebody should do a study. There are no studies here. This is not a Kathy Fizzler talk, okay? She gave a great talk at UBC 2 weeks ago. So yeah, I've struggled with exactly what you're saying, but I'm willing to format this better. I'm not willing to put it right at the point of error. And maybe I'm wrong.
That's a great answer, thank you.
Oh, Ben.
Okay, hello, Ben Greenman. I want to ask more about thoroughness. So you said students need to work a little bit harder to get from 99% to 100%, but if you pick tough tests for thoroughness, like you need to test the number 601, then it can be very frustrating for students. Like they need to reverse engineer what the TAs were thinking to get that 100% for thoroughness. So what's your guideline for picking the thoroughness test?
No, hang on. Yeah, no, I mean, we're not.
I know you're not adversarial, but.
We're Canadian. We're this side, we're on the other side of the border. You're not allowed to say 601 has to exist unless there's a design rule that says 601 has to exist. So in that example, the reason 89, 90, and 91 have to exist is because it's an integer boundary condition. And if all you have is 85 and 90 and 95, and somebody accidentally types 91 in the code, the tests are going to pass, right? So no, it's not that the TAs got together and said, it's not that. It has to be real.
This is too simple of an example. What about recursive data? Like lists, they need to be sorted? Or...
So you're saying, so we have a design rule that says that if you operate on arbitrary size data, of course you have to have a base case test. It probably would be good to have a one deep test just for simplicity for your brain, but the one deep test doesn't really add to testingness, it adds to exampleness. But you also need to have a 2+ test in which every recursive condition happens past the first. That's the rule. So yeah, our rules, there are mistakes that our rules won't catch. Okay, we're not trying to, we're not trying to turn it into a fourth-year software engineering course, right? It still has to be fair within what we've been talking about. Okay, faulty function testing is different, and we're very clear about this. That one is, if we make a function that is a simple mistake from the right answer, you should find it. And faulty function testing is always worth very little, because it's just, But, on a problem set, I'm willing to make 1% on, did you think about that greater than being wrong? No, not that one.
You've been disallowed. Seriously, though?
No, this one here.
So I really like the grading DSL, but I want to know how tied is it to BSL, or could I just apply it to arbitrary racket in my fourth-year software engineering course?
If it had been written by somebody who really understands the language-oriented framework of Racket and who uses defined syntax properly and uses sharp-lang properly, if you had a grad student who understood all that, and who could rework this to have those properties, you'd be all set. It was good in the 80s. We had def macro, we had backquote. It was all great. I don't actually believe that, but it was easy.
All right, I think we're just about out of time for questions, but I just wanted to say one of the things that's interesting is that you're talking about teaching this class at scale, but I really liked how you still emphasize some of the human factors that help it succeed at scale. So thank you, that's really interesting.
Thank you all.
All right, let's give it up for Gregor.